Okay. And let me just share one screen as I want to do that with with the flyer in it for a second before I introduce John. And so you'll see that. And I apologize if I go in and out a little bit on that. What I will do now is put it on speaker. And so I can do an introduction. And let's see. You guys can see me okay?
Mm-hmm.
Great. Okay. So we're thrilled that John is joining us this evening. We're trying a little bit of a twist this coming year. We'd have subject matter experts like John in different areas about the climate, as well as people who are studying how climate education unfolds in the classroom. So we're thrilled that John is joining us this evening. John was born in Schenectady, New York, and raised in Puerto Rico. He attended the meteorology program at Cornell University and was then hired by the National Weather Service in 1984. In 1991, he was hired by the Spanish language television network Univision and founded his company Climate Data Corporation. He has won 3 Emmy Awards. In 1993 for 48 Horas Antes de la Tormenta, 48 Hours Before the Storm, in 2005 for his coverage of Hurricane Wilma, and in 2010 for a special program about the upcoming hurricane season. John has the seal of approval from both the American Meteorological Society and the National Weather Association. He was given the prestigious distinction of Certified Consulting Meteorologist from the AMS. In 2003, he became Chief Meteorologist at WSCV in Miami. In May 2009, John made the switch to English language television, joining NBC's WTVJ in Miami. John is the longest tenured broadcast meteorologist in South Florida, serving as a reassuring television presence for nearly 3 decades. His tropical weather acumen and steadfast character guided South Florida viewers through Hurricanes Andrew, Irene, Katrina, Wilma, and most recently, Hurricane Irma. And we know that's going to be really important for all of us here to have that kind of steadying influence. For his life-saving work during the 2017 season, John was recognized with the John Coleman Broadcast Award at the National Tropical Weather Conference. John's volunteerism extends from board of directors participation in multiple South Florida nonprofits, including his current service as first vice president of CLEO, to mentoring young scientists, to having piloted for Angel Flight Southeast, an organization that provides free flights so children and adults can have access to far-from-home doctors. John, we're thrilled to have you. Thank you very much, and please take it away.
Thank you. Thank you, Scott. I appreciate that. Thanks for all of you for being here this evening. A couple of things. So the bio is a few years old. So as far as my presence on television in South Florida, it's now 33 years and counting. And yeah, prior to that, I was a National Weather Service employee. Somewhere along the way, I got myself a master's too. That wasn't too long ago. I did it after I was middle-aged. I'll generously say, in environmental science and policy at Hopkins. So always interested, not just in meteorology, but also, of course, the changing climate, and we're going to look at that today. But also the environmental threats that, of course, mankind has caused, and how to alleviate that as we go forward. One thing I wanted to share before I went into the presentation, since this is a teacher's thing, I am vice chair of the board of directors of the CLEO Institute, and the CLEO Institute does have programs for teachers K through 12, professional development training on climate change. So, just go to the clioinstitute.org website if you want to know more. And now, let's see, do that. But then I put it in presentation mode, I hope. And there we go. So I presume you're seeing the front page of my presentation in presentation mode. There's my contact info, both on social media, which I am pretty active in. And in case you want my email for anything, it's right there as well. All right. So, if you're in Florida and Georgia, like the people on this call are today, let me get the time. Okay, should be done by 8. Okay. So you're familiar with these threats, right? What threats do hurricanes produce? Well, a lot of them are water threats. And historically, the biggest water, namely storm surge. We had an example of that in 2022 with Hurricane Ian when it hit Southwest Florida, and we lost dozens and dozens of people to the storm surge. But excessive rainfall has always been a threat, and seems to be an increasing threat from the freshwater flooding. Obviously, the windstorm, that's what people tend to think about first when they think of hurricanes, is winds. And yes, there can be tornadoes when hurricanes come through, both on the outer bands of the hurricane as it's approaching or passing by, as well as in the core of the hurricane inside the eye wall. All right. So a mixed bag here with greenhouse gas pollution, other types of pollution, and the changing climate. So generally speaking, when you look at the entire tropical belt around the planet, there doesn't seem to be a trend up or down, or if anything, the models are indicating that in the future there could be a lower count of tropical cyclones around the planet. Now, tropical cyclones is the generic term that encompasses tropical depressions, tropical storms, and hurricanes. Hurricanes can have other names. They can be called cyclones. They can be called typhoons, as you know. So there might be fewer of these around the planet over the long run. But the problem is that of the ones that are forming, we're seeing a greater proportion of the ones that form reaching major hurricane status or super typhoon status, if you want to look at another part of the world. And these are the ones that cause the greatest destruction and, of course, claim the greatest number of lives. We are seeing more of these rapid intensification cycles, which leads to more Cat 3, 4, and 5 cyclones or hurricanes or typhoons worldwide. There are numerous recent examples, but I think a very recent example which astonished a lot of folks was Hurricane Otis in the Eastern Pacific, which in the span of about a day went from a moderate tropical storm to a Category 5 hurricane and struck Acapulco, where they were simply expecting a strong tropical storm, maybe a low-end hurricane, ended up being a Cat 5. Nobody that I know of forecasted it. The National Hurricane Center did not forecast it. So don't think that they're infallible, all right? I mean, generally speaking, they're excellent. They are the top specialists in the world, but that's one forecast that they'd like to have back. So all this is happening because the storms that are out there are encountering a different set of conditions than what they used to encounter in the 19th and 20th century climate, right? Or going back further. Right now, they're encountering juiced up conditions, particularly because sea surface temperatures are so warm. And we'll go into some of that as we go forward here. There's been a trend, as you can see here, this is in the last 125 years or so, around the planet for warming oceans. And the warming isn't just at the surface, it's deep enough that if you mix up the surface and you allow for a little bit of upwelling of the waters that are just beneath the surface, it's still warm. There are some exceptions to that. As you can see off the coast of Greenland there, it is cooler in the last 125 years. You might, as teachers, particularly in earth sciences, already your mind might be figuring out what's going on there. Yes, the Gulf Stream is slowing down, so you have less transport of warm waters up towards that part of the world. In addition, there is a good deal of ice melt coming off the ice caps in Greenland that's contributing to the cooler temperatures. And of course, it's making the water fresher, in other words, less salty. If the water is less salty, it doesn't weigh as much. And therefore, it slows down the Gulf Stream. In other words, if you have heavier water that's salty and heavier, it sinks down readily. When you have less salty water, the water is not as heavy, and therefore it doesn't sink as fast. And there's other things going on. You've heard of some papers that are out there indicating that the Atlantic Meridional Overturning Circulation, or AMOC, has a chance of shutting down this century. And of course, the consequences there would be grave. Think the sci-fi movie Day After Tomorrow kind of thing. Not happening from one day to the next, like in the movie, because that is Hollywood. But long-term consequences would be like that, right? Much cooler Europe, much cooler UK, all that region, and sea level rise increasing tremendously. And by the way, because the Gulf Stream is slower, that is why the east coast of the US and down here into South Florida, we're seeing some of the fastest rises in sea level of the entire planet, right? Because the sea, it's increasing, whatever it is, 4 millimeters a year. Doesn't sound like a lot, but here in South Florida, we've seen 7 inches in different metrics, different systems, 7 inches of sea level rise since the mid-1990s. So in 30 years, we've seen, what's that, about 14 centimeters, 15 centimeters of sea level rise just in that time. So it's much faster here than it is elsewhere. Anyway, I don't want to mix too many things into the one talk here, although we will talk about sea level rise and its implications for hurricanes. But the bottom line is, as these oceans are warming, tropical cyclones around the planet are trending stronger. So the percent of all storms that reach major hurricane status has a trend line that points up. And that's concerning, because that means more Irmas, more Marias, more Harveys, more Dorians, more Andrews, more Ians, right? And I can keep naming storm names. You can try to fit a trend line here too, right? And it would point up as well. The number of Atlantic tropical cyclones that are undergoing rapid intensification, which by definition is an increase in intensity of 30 knots, is 35 miles per hour in 24 hours. And there's hurricanes that do it, or storms or hurricanes that do it a lot faster than that, like Otis, right? But that's the minimum. If you want to classify a system as being as rapidly intensifying, it needs to cross this threshold. 79% of all cyclones that reach major status go through rapid intensification cycles, 79% of them. So generally, you always see that happen. And rapid intensification has real life consequences. Look at the hurricanes that have gone through rapid intensification and look at the damage that they've produced. Katrina in 2005 and Harvey and Maria in Puerto Rico, Sandy in the Northeast, such an odd hurricane that took that left turn, right, to go into New Jersey. Ida was that hurricane that went up through New Orleans, through Louisiana, Southeast Louisiana, and then produced some massive flash floods, and loss of life in the flash floods, even in some of the major northeastern cities where people drowned in their basements because they didn't realize the water was going to increase so quickly. So as we get these stronger tropical cyclones, the damage is just multiplying. So Florida's costliest disaster in history was just 2 years ago, Hurricane Ian, greater than $100 billion in damage. Because people didn't have flood insurance, all these retirees, and a lot of these retirees were from blue-collar jobs in the Midwest. They put their entire nest egg into their double-wide, place in Fort Myers, just to give you an example, right? And they had no flood insurance, and it was washed away by the hurricane, and they lost everything. Not to mention the people who lost their lives. So you can see these geographically unfortunate states, at least for hurricanes, have seen a lot of these disasters recently. As a matter of fact, in the US, the time between each billion-dollar disaster is now down on average to 11 days. Only 11 days between billion-dollar disasters. And sure, there's more things in harm's way. There's no doubt about that, right? I mean, we've built up so many things. People want to live at the coast. But there's also an element here of stronger, slower moving, more impactful hurricanes affecting the coastline. Not to mention derechos, tornadoes, and flash floods, and all the other things that are also being driven, all the extreme weather events that are being driven, partially at least, by the changing climate. So you math teachers out there will enjoy this. So this is a logarithmic chart. There's your logarithmic scale on the left. Wind speed is on the x-axis. And if you remember Irma, long-lasting Category 5 hurricane, one of the longest-lasting ones, if not the record holder, for how long it stood at that intensity. So here is Irma's return period based on the 20th century climate, right? And you look at the blue dot there at the intersection with a line, and you kind of go to the left there, and I don't know, looks like once every 700 years, approximately 750. But then, fast forward to later this century, and the return period might be every 70 years instead of every 700 years. And you think Barbuda has fully recovered from Hurricane Irma? I haven't visited Barbuda, but I guarantee you they have not. So here's one for Puerto Rico. And this is within 150 kilometers of 17 north and 64 west, which I can tell you is a spot just south of St. Croix in the U.S. Virgin Islands. And I mean, if a hurricane crosses St. Croix or just south of there, you're pretty much guaranteed that it's going to go into Puerto Rico. All right. So return period of a hurricane like Maria, which was just below Category 5 intensity. It was sustained winds were 155 miles per hour when it reached Puerto Rico in 2017. Instead of once every 200 years, it might be once every 20 years. So 20 years, right? This is more of a rhetorical question, but, can a society possibly sustain a hit like that, a catastrophe of that nature with that frequency? I remember some interviews from Hurricane Dorian in the Abacos, and people were reminiscing on Hurricane Floyd, which had hit them about 20 years earlier, and saying, yeah, we're not fully recovered from Floyd, and now we have to deal with Dorian, which came by that area. All right, so that's just focusing on wind speed. Okay, I mean, all these, a lot of this was wind speed yeah, when we talked about billion-dollar disasters, there's other factors in there in addition to wind speed. So let's talk about some of those factors here. I'm sure you're aware, but a warmer atmosphere can hold more water vapor in it. And therefore you can squeeze more precipitation out of a warmer atmosphere. That's why when it rains these days, it rains harder. You're also seeing the entire hydrologic cycle speed up, because since temperatures are warmer, when you go into a prolonged dry period, evapotranspiration is happening at a faster pace. Everything is drying out quicker, and flash droughts can happen easier too. So it's really the entire hydrologic cycle is at a faster pace nowadays than it used to be in the previous century. In addition to that, you should keep in mind that we're noticing hurricanes moving slower. The jet stream seems to be slowing down, meandering more. Think of what happened with Sandy. Think of what happened with Harvey, right? And slower moving hurricanes are obviously going to be able to deposit more rain. Sea level rise, a big factor in all this. This is just looking at the Tampa Bay area. If we end up with 3 degrees of global warming, we're already at 1.2. We're going to blow past 1.5. Sorry, but that's reality, despite the aspirations of the Paris Climate Agreement. And it's going to be very difficult to meet the 2-degree goal as well. So if we get to 3, which is totally within the realm of possibilities, this will be the consequences in and around Tampa Bay in terms of permanently flooded locations in that area. So then imagine what happens, here in South Florida. And this is an example with 2 feet of sea level rise versus no sea level rise, a hurricane with the intensity of Andrew coming into Metro Miami, where you see kind of Port Miami there in the southeastern or bottom right-hand corner of each image, Miami Beach, the Barrier Island, and the big metro there. And you can see the consequences of what a storm surge like that would be. I mean, sea level rise matters for storm surges. And people don't understand that, given, look at a beach, it's pretty flat. The run up of the waves can go far onto the beach. Why? Because it's relatively flat in most locations. South Florida is a very flat place. You get 2 feet of sea level rise, and add on top of that a storm surge, and it's definitely going to matter. Now, there are some good, positive things happening here with the science. We've become better forecasters in terms of hurricane trajectory. The cone indeed is narrower these days than it used to be. So there is more accuracy in track forecasting. There is some improvement in intensity forecasting, but maybe not as much as we want. And I just gave you the example of Otis and what a disaster that was. We're getting better modeling. The models simply take the equations of motion that define the behavior of the atmosphere, which behaves like a fluid, and crunch numbers through going forward in a grid that's getting finer and finer these days as you model the atmosphere. So through that process, we're just seeing better and better forecasts. And now there's so much computer power that you can run the same global model 50 times with slightly different initial conditions. This comes from Lorenz and his science, which is the butterfly effect, which you may have heard, where, the butterfly flaps its wings in Japan and it might impact a tornado forming in the US. Well, what you do then is you take the European model, and you ingest all the data. That's called data assimilation. But then you give it slightly differing initial conditions to see what will happen. And the European Center has enough computer power to run their model 50 times, 4 times a day. But the US doesn't have enough computer power to do that, so we only do it 20 times, 4 times a day. And as you know, the European model forecast is considered the most accurate in the world, better than the US's. That might be it. It is. And if I did that, I finished in 20 minutes, which is not bad. So I will stop sharing. My dog opened that door. I gotta shut it because it's super humid. Just a second.
While John's doing that, there's a small enough group here of 11. I think if I put you on, if you put yourself on gallery, you could probably, John, see if somebody has their hand up for a question, or they want to do some brainstorming with you about a lesson, or if they're not showing their screen, maybe they want to put a virtual hand up. I see Charlie. Well, you want to go ahead and recognize, I guess, Charlie, and then maybe Ellen. That's Ellen's hand.
John, thank you so much. I really appreciate it. I didn't hear much about what's causing all these changes. Are you intentionally staying neutral for diplomatic or political reasons, or are you allowed to talk about, say, the influence of our animal agriculture on the planet, or can we sequester carbon and perhaps make some changes? I don't know.
Yeah. No, I have no restraints. I just assumed, 3 in 4 Americans are accepting of the fact that the planet is warming, and the majority of Americans accept that it's caused by humans. So this is not as controversial a subject as it used to be. It needs to be, and therefore it needs to be talked about more. It should not be a taboo subject like religion and politics at the Thanksgiving table. I think if you find common ground with folks, just find something that, say, a person enjoys and how that's being impacted by global warming, and just kind of not open with global warming, but say, hey, I know you enjoy cycling. You notice any differences? Has it been a little harder in summer for you to cycle or whatnot? I mean, that's just kind of a way to break the ice. Find common ground, meet people where they're at, and talk about it. So to answer your question, I didn't talk about that because I felt no need to talk about it. Everybody knows that.
Thanks. I appreciate that. I was just making sure that it wasn't
Yeah.
being presented this way for the teachers' benefits.
I mean, even if I mean, you guys, I don't know how you do it. In the state, I mean, I have no idea how you guys are doing what you do. You're all heroes, doing it for the kids, but yeah, even being here in Florida, I am allowed to talk about it. I just assumed that it was a given, that you all understood that the burning of fossil fuels has led us to this point. It's going to get worse before it gets better. And it's quite alarming, and it's already here. It's not something that we're, oh, this is going to happen, and the famous polar bear pictures, and no, I mean, this is here and now. It's already happening. We're seeing the consequences, and it's only going to get worse. So, and I don't know how you convey that to the kids without them being, what's the word? Triggered or offended, and then having them report you to their parents, and then having you being arrested. I don't know how that works. And maybe I'm exaggerating, but this is what I hear that happens if you teach certain subject matters to the kids, and maybe climate change is one of them. I know that they eliminated it from there's certain textbooks in this state that can no longer have climate in them, because the textbook publishers are not going to be allowed to sell them here. So anyways, fun times.
Ellen, you got some good points that we may come back to, John. Thank you very much.
Yeah.
And thank you, Charlie. Ellen, you had a question, right?
Yeah, I have a comment and two questions. So the comment is along the lines of what you were just saying, John. In the city of Gainesville, we had a climate director until recently, because they had to change her title to resilience officer, because we can't. And we know that Gainesville is in the legislature and the governor's sites. A lot of preemption issues going on here that are, yeah, Susan knows, and that are really horrifying. But that's my comment. I actually had a technical question and a generic question, and I appreciated your comments to Charlie. So let me start with that, the broader question. Meteorologists are one of the most trusted professions in the country. I think you're right up there with astronauts, and above doctors. So I don't hear, I don't hear the Weather Channel or even our lovely WUFT meteorologists talking about exactly what you just explained in 30 seconds. Is there any kind of movement for folks who understand as you do? They all must understand, to broaden the conversation, a la Catherine Hayhoe, which, you were just right out of her playbook, to say, yeah, this is what's happening, and here's what's going to happen, and here's what has been happening, and here's why it's so hot, and here's what you could do. Keep it in the ground and take the carbon dioxide out of the air. Boom, period, the end. What's going on with any opportunity? Can you do that? Is there a national movement? Can we encourage our meteorologists to do that?
Oh, you should. I am amongst a handful of broadcast meteorologists who started to do this 20 years ago, which is provide climate context in weather segments, and particularly in weather segments. Maybe 20 years ago, not so much in weather segments, because extreme weather was not occurring as frequently 20 years ago, and therefore the opportunities to make that connection between the observed extreme weather and the changing climate didn't come up as often. So instead, presenting on climate 20 years ago was more in the form of maybe not in the weather segment, but the broadcast meteorologists reporting on the science. So we would do like a news report, like you've seen. Of course, 20 or even 10 years ago, it was always a challenge, because journalists are not scientists, and journalists are trained to present two sides to every story. But the scientific method does not yield two sides, right? It yields a conclusion, which we continue to iterate on, right? We will continue to experiment and, try to disprove, oh, this guy's wrong, I'm going to prove him wrong. And some person will do an experiment and try to prove. So the science continues to iterate, but as that's happened with climate science, all it's done is reinforce what we've known for decades now, right? That the greenhouse gases are doing what they're doing. So many more broadcast meteorologists are doing that today than used to do it 10 or 20 years ago. And that's very positive. However, there's still not enough doing it. Like, for example, in the Tampa market, one guy, Jeff Berardelli, look him up. Jeff Berardelli is terrific. He's also a Cornell grad, may I add. Always making those climate connections on TV in a market where it can be relatively challenging to do that because of the politics of that market. Okay. There's examples of and I admire her tremendously. Her name is Elisa Rafa. She is now on CNN, but she started in Sioux City, Iowa, Then her second market was Springfield, Missouri, and her third market was Charlotte, North Carolina. And in every one of those markets, she found a way to connect with the people. So when she was in Sioux City, she talked about how climate was impacting farming, right? And when she went to Springfield, I think she had two better known stories. One was on the impact of the changing climate on beer, and the other one on chocolate. And then of course Charlotte was a little bit different than those other two markets politically. And now she's at CNN doing it nationally and internationally. So she's moved up in the world. Bottom line is there are more of us doing that, but not enough. It should be everyone, frankly, because if broadcast meteorologists are asked to, present on this weekend's meteor shower, or tell you about the next rocket to leave Cape Canaveral, or talk about some earthquake in Chile. If we're going to be your Earth scientists, then should we not cover climate? Of course we should.
Of course.
So yeah, I would urge you to contact your local TV weathercaster and ask them to get with it.
Okay, thanks. And then my technical question, yeah, okay, good. I don't see any other hands. This whole thing with the spaghetti models, and you're saying the European model is better. And I know that our group understands climate modeling. Could you talk a little bit about what are the inputs and why there are so many of those little lines?
Well, so when you talk about the spaghetti plot, it's a plot of a bunch of different models. So the American GFS and the German ICON and the European ECMWF, and the Canadians have a model. I mean, there's probably half a dozen countries and or groups of countries that are producing a global model. So you'll see all of those lines, and then you'll see lines for the specialized models that are only run when there are fledgling hurricanes or fully formed hurricanes, both. And they'll mix those into those spaghetti. So you'll end up with I don't know, probably like 10 or 12 lines. And then one of those lines will be a consensus, kind of a blend of all the others. So that's how it gets so spaghetti-ish.
It looked like you had like 20 on the little slide.
Well, no, yeah, but see, that's different because with that, and I guess I can try to put that up again. Because those are ensemble forecasts. So
I'm sorry, they're on what kind of forecast?
ensemble.
Ensemble forecast. Yeah, look,
right
I mean,
there,
it's like 20 or
ensemble.
30. Yeah.
Right. So that's what I was telling you regarding running a model with slightly differing initial conditions
Okay.
to see what happens in the atmosphere as you go forward with those slightly different initial conditions. And why are they doing that? Aren't the conditions the conditions? But there's always some uncertainty. There's always some, because even though, and this is something the Europeans do very well as well, the Europeans are terrific at data assimilation, and they wait longer before running their model. So these models are run in universal coordinated time at noon, 6 p.m., midnight, and 6 a.m. right?
Right.
GMT time. But the Americans don't, they want to get their model quickly because they want to serve. Remember, weather impacts commerce and everything, almost everything this country does, from aviation to transportation to production, agriculture, et cetera. So the Americans want to get the model out as quickly as possible. They don't wait as long. They're not as good at data assimilation.
Huh.
The model suffers. The model is not as good as the Canadian model is. I mean, sorry, the European model is. The Canadian's worse. Anyways, so the Europeans wait longer, and then okay, so they're better at data assimilation. Isn't the data the data? Like, if the temperature at 500 millibars, which is around 18,000 feet, 18,000 feet altitude, and the temperature above Miami happens to be minus 10 Celsius. Well, isn't that the damn temperature? That's the temperature. Yeah, but what happens in all the spots in between? Like, how do we really know what the temperature is between Miami and Melbourne, right? We don't have a data point there. And that's why there can be some uncertainty in terms of the initial conditions of a model, because the interpolation of what happens in between each data point can be slightly different. And that's why the input can be slightly different, just to see what will happen. And so we've realized that ensemble models are better than the single run model, the quote unquote operational model. So when you look at, these days, if you want to be an avant-garde meteorologist or weather aficionado, you should know that gone are the days of looking at just one model run. If you're going to look at the European, you need to look at all 50 runs to really get an idea. And well, how do you do that? Do you have enough time? Well, there's tools for that, right? I mean, you can have blends of those models. And of course, if you're a good forecaster, you know what some of the biases of the models are. And that's why the human element in the forecast is always a good thing. And that's why your weather apps suck.
Oh.
Your weather apps suck because there's no human in that forecast. All the weather apps are doing are taking one run, not even the ensemble. They're taking one operational run of the model of their choosing. Could be the American model. If you're using windy, it's going to take the European model. And then it's spitting out a supposed hour-by-hour forecast 3 days from now.
Right.
I mean, it's supposed to tell you at 1 o'clock on Friday, what it's going to do on 1 o'clock on Friday. Really? I mean, you think that's accurate? It's not. But you're getting that single data point. You're extracting it from that single geographical location on the surface of the Earth. Whatever the model said, that's what you're getting. And more often than not, it's not going to be right.
What app should we be putting on our phones if we would like to track things?
I just know well, to track radar. Now, radar is real life. Radar is what's really happening. It's remote sensing of rainfall. I use a free one. What's it called? I think it's called My Radar. Yeah, My Radar. It's free. It's good.
Thank you.
But some people pay for StormScope. I think it's called StormScope. And it's, StormScope gives you all kinds of interesting data. If you're a weather weenie, you'd really enjoy StormScope, but you got to pay for it. But for simple rain tracking and looking at radar, that's real life stuff, and that works. I'm just telling you that, the iPhone's weather app or any of those other ones, that's not how I brief myself. If I'm going to a city, if I'm traveling, right, and it's in the US, what I do is I go to the National Weather Service's webpage and I look for the forecast for that city, because I know there's a human involved in that, and the human understands the biases of the models in his or her particular area. Like, they know, oh yeah, here's the GFS telling me that it's going to be 92 degrees in Sioux Falls, but I mean, I know it runs hot. I know the GFS runs hot, so I'm going to go 90, right? So the person knows based on experience. Forecasting is a science, but it's also an art, and having experience really helps you become a better forecaster.
That is really.
Sorry, I talked for so long.
Yeah, no, that was really useful. Thank you. Thank you. What about Florida Storms, that app?
I've never heard of it.
No, okay.
Yeah, there's so many of them.
Oh, that's a very interesting. Yeah, that's exciting conversation. Actually, I was thinking, how that kind of little bit that you just shared, sort of the models of versus and the intervention of humans and why that's important. It's really interesting and an important thing to share with with students. I'm trying to think, I'm looking at our screen right now and I'm wondering, I don't know
Well, it's-
Jane or Constance and Karen. I don't know if are you teachers in Florida? And if so, would you know what? No. Okay, I don't know. Karen, are you teaching?
I know that there's, where
I-
is this? Oh, Lori is the reporter from the Invading Sea.
Right.
Yeah, Lori, probably, there's a lot of nuggets here that you love to have me write a column on for the Invading Sea. I've written for the Invading Sea in the past, and sometimes I hit on some of these subject matters. Um, but yeah.
Constance, are you a teacher? Oh,
You're
okay,
muted.
you're gonna have to unmute. Unmute.
Unmute.
There
I
you
did
go.
40 years. I did 40 years in Florida schools, senior high and elementary as a media specialist. And I'm fascinated with weather and with the hurricanes, plotting their courses and everything. And I've been traumatized in the past. I lived through 2004 where we had one every 2 weeks, and it wasn't easy.
No,
The kids
no.
were affected too. The kids had problems too.
Yeah.
In fact, we were talking, one of the stations should start running cartoons and stuff, during the storm instead of the constant weather stuff. The kids are,
Oh,
That's a great idea.
yeah, it is. I mean, it's not, I think it just lifts everybody up a little bit, but the kids, that 2004 was a very, 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 very dark period.
Yeah. Four hurricanes came through Florida.
Yeah, and Eustis, where I am, which is centrally located, I think several of them passed right over. We were right at the nexus of it.
Polk County, I don't know where
Yep.
that is in relation
That's
to
next to me.
Well, if it's next to you, 3 of the hurricanes went through Polk County. 3 of the 4 went right through that area. So you lived through at least 3 of them. The only one you didn't live through was Ivan, which hit the Panhandle.
Yes.
But
My
Charles,
nephew was
Francis,
living in Celebration, which is Disney. So it went right over Disney, those 3. And because Celebration had buried all their utility lines, he never lost power through any of it. And
interesting. That's cool.
some of his neighbors thought he was possessed or something, but that's something we need to harden our utilities too.
Mm-hmm.
I was born in Florida and lived here all my life, and it's the storms are getting much more fierce than they used to be.
They are.
And they don't move. They don't move off quickly enough.
Correct. Yep.
They just hover like a.
Yeah, that's some of the stuff we just discussed.
Yeah.
Exactly.
I have lived it, and it's horrible.
Mhm.
And when you're a teacher and you come into work, we were gathering books for other schools that had been swamped because they don't have enough money. These little counties don't have enough money to replace the amount of stuff that these kids need.
Anything
Thank
else you wanted to know about weather, but we're afraid to ask? Or
Yeah,
climate?
John, here's a question for you, and just comment quickly on that kind of topic of traumatization. When WLRN yesterday actually had a story I was listening to, and while I was transiting on with a psychiatrist in the Boca area, talking about trauma that hurricanes can have with children, and sort of how to work with kids and avoiding those kinds of things. Yeah, so it's definitely a topic on people's minds in Florida, I think, and maybe something we want to think about more about sharing out with our group here in the future. My question for you, and you did this wonderful job of in talking about Ellen's questions about modeling using the computers and that what tell us a little bit about how the data is gathered from some of the new technologies. I mean, you got all kinds of new ways of gathering this data as well that are interesting, and that seems to be changing and maybe contributes to more accurate forecasts? I don't know, or what are they, what's the future of sort of the data collection for storms, and how will that impact our forecasting?
No, you're totally right. I mean, it's already evolved a ton. Back when I started my career in the National Weather Service in the 1980s, it was the surface observations, at an airport, this was done by humans. What percent of the sky is covered, how high are the clouds, temperature, dew point, wind direction and speed, barometric pressure. So surface observations were like that. Then you had, and by that time you did have weather satellites, but the satellites were only looking at the clouds. I mean, they were just taking pictures of clouds. These days, satellites are remote sensing everything from space, not just clouds. They can give you a profile of the temperature of the atmosphere from the surface to the stratosphere. It gives you the amount of humidity that's out there from space. And there's both the geostationary satellites, which remain over the same spot on Earth the entire time, but you also have the polar orbiting satellites, which have lower orbits and help in, for example, looking at wind speed and direction at the surface of the Earth, which is very helpful when you're trying to detect whether a tropical wave is turning into a tropical depression or storm, because you start to see that circulation, and the polar orbiters can do that. Weather radar is another remote sensing instrument that these days can provide a lot more data than it used to, especially because of the Doppler, the application of the Doppler principle. So we're seeing the movement of the raindrops in relation to the radar's location. Are they moving towards or away? And of course, through trigonometry, you can figure out, what the speed and direction of movement actually is. So it's not just towards or away from the radar, but if it's tangential, it can't be totally tangential, but if it's at an angle, you can figure that out through trigonometry too. Obviously, if the raindrop is moving in a direction perpendicular to the radar beam, then you can't measure its movement because it's cutting right across, and it doesn't work, right? It has to be either towards or away for you to be able to do that.
Hopefully the wind's not that fast.
Yeah. So yeah, I mean, all those are some examples of how things have evolved in terms of data acquisition, which is now much more robust. No corner on Earth is left without some form of radar, remote sensing. So gone are the days of depending on the weather balloon, right? Miami was one place where they would release a weather balloon, and we still release a weather balloon. I mean, that data is important, but everything in between is being filled in as well, with satellite data and other things. So those are some examples.
Great, thank you so much for that. Yeah, things have definitely been changing. I'm looking at the clock now. We're almost closing in on our end of our hour, so I don't know if we've got anybody who hasn't asked a question. David, did you have a question or a comment for John?
You're muted, David.
I'll make a comment. I would
Jane.
just like to thank you very much, John, for your presentation. I thought it was excellent. We need a lot more people to hear it. I'm from Lake County, and my experience that climate change is a dirty word with regard to our county politicians. They talk about it frightening people, So I don't see any movement to really prepare and address climate change in our county.
David, did you sorry, you want to unmute yourself now? You're still muted.
You're still muted, David.
Can you?
No, he doesn't want to say anything. Because I don't think he can. He's talking.
Yeah,
David?
we can't. David, we can't hear you. You got to
Okay.
unmute.
We
Yeah,
never-
There you go.
I don't know why I can't figure that out every time on one of these calls. just very quickly, I heard a number of comments that suggest concerns about kids and making them aware of climate change without scaring them or causing them undue distress. The group I've been working with, it's been a while, so I can't cite it right off the top of my head. There are several groups that are looking, they have protocols, guidelines for how to talk to kids about these changes. And if there's an interest in that, I can dig out the references and send them to you, Scott. My own daughter is involved in that. She works for UNICEF, and they've done an international effort to gather data about kids' concerns and how they can be addressed. So if that's something, I think I was picking up on that as a thread throughout all this, and maybe I can contribute to the group as an outsider from another state by circulating that through you, Scott.
Great, thank you, David.
Thanks,
Appreciate
Stu.
that. Susan, did you have a quick comment or question?
I just wanted to finish on a funny note, if I could share my screen for a moment.
Go right ahead. I think it's open for you to do that. And then I'm going to share what after you do.
Just, this is another form of a spaghetti model.
A literal
So-
spaghetti model, yes.
I love
thank
it.
you.
I've never seen that. That's cute.
I'll send it to you.
I'm gonna just share one thing, and first of all, let me thank John so much for this wonderful presentation, and we deeply appreciate you and your work and your ability to communicate some of these maybe difficult concepts, and I think you've done that very clearly, and I hope many of our members who RSVP'd or are waiting to watch this at a time maybe that's more convenient with them, and we'll be able to see that and pass that along to other of our educators that are part of the network. I do want to share, I think you can see that next, we're having our next presentation in September, the end of September, from a language professor, language and literacy. I know David will enjoy this. Literacy and English language arts teaching for socio-ecological futures in Florida, with Dr. Alex Panos at USF, and I hope some of you will join that, and so I appreciate that. And I'm gonna pause the share, stop that share here. And then thank you all very much. John, thanks again for appearing, and appreciate everybody's appearance tonight. And we still got a bit of a hurricane season to go, but thanks everybody, and I hope you'll keep this in mind when we have some of our upcoming storms. So thank you again. Thanks again, everybody.
Thank you. Thanks. Thanks,
Bye.
everybody.
Thanks,
Bye-bye.
Scott.
Thank
Bye.
you. Thank you.
Really great.